What do you think a piecewise function is? What's a piecewise function? Yes.
Function made up of several parts.
Okay. Or pieces. I know. But, it's piecewise, so I watch. I expected to use the word. But good. It's a function that has different pieces. Okay. And in this case, when we say pieces or parts, we really mean different formulas. Okay. Because, for example, 1 over x has 2 pieces or 2 portions, 2 components on the graph, but it's all the same formula, 1 over x. Now, a piecewise function is a function that has multiple formulas. Okay. So I'll show you what I mean by that and typically how they look like. And we already know one piecewise function, even though it comes hidden in the form of a nice little formula, but it's really a piecewise. Okay. So let me illustrate with an example. So consider the function f of x equals absolute value. This looks like one formula, but there are really 2 formulas here. Okay, that are hidden because how do you evaluate this function? Do you just plug in and that's it? And do arithmetic operations like addition, subtraction, multiplication, division? Or you do something else? When you evaluate this function, what do? You ask yourself a question. What question do you ask yourself when you want to evaluate this? Even if you don't ask it yourself, your brain is really asking the question itself. So what question do you ask yourself when you evaluate this? For example, what's f of 2? 2. What's f of negative 2? What is it? 2. How do you know that? What did you ask yourself any question to say this? What did you do? Oh, just drop the negative? That's what comes to your mind? Okay, but remember, if you have a computer, imagine that you were a robot or a computer. You cannot reason this way. You need to reason in a more systematic way. So really, what is it that you're doing? What does it mean to drop the minus? Here, there was no minus to drop, so you kind of needed to scan and say, is there a minus or not? If there is a minus, drop it. If there's no minus, don't do anything. Do you understand what I'm saying? This is happening in your brain, even if you don't do it. This is if you don't do it consciously. Like, do you think about breathing? Are you thinking right now how to breathe? You just do it. Right? You just do it. That's the same thing here. You saw this and you say 2 or 2, but unconsciously you say, oh, is there a minus? If there is none, just keep it how it is. If there is, remove it. Even if you don't go through all of this thought process, this is happening in the background. Okay? So those questions that you are asking, which is there a minus or not, that's equivalent to say, is this positive or negative, right? You ask for the sign of the input. Those are questions that you are asking, and depending on the answer is what you do. Well, this can be written formally as follows. If x is positive, let's throw in 0 in here. Doesn't matter which one of the two we throw the 0 for this case. But if x is greater or equal than 0, do we do anything to the input? No. So we just keep it as it is. But now, if x is negative, do we do something to the input?
Change the sign.
What do? We change the sign. We remove the negative. How do we remove negative mathematically? What operation does this? I mean, we're trying to define the absolute value. You multiply by negative 1. So the absolute value is really 2 formulas. Okay? It's the function y equal x, but it's also the function y equals negative x. Which one is it? Well, it depends. If you are in a position in which x is positive, so if you are to the right of the y-axis, you're looking at this formula. And this is all you care about, y equal x. If you are to the left of the y-axis, meaning if your input is negative, you're looking at this formula. Do you understand? So, technically, what's happening here is that when you evaluate f of negative 2, you say, well, negative 2 is negative, so I should use my second formula. So it's really minus 2, which then, of course, becomes 2, etc. Okay? So the point is that this is a piecewise function, and this is how piecewise function will look. Okay? They will have a little curly brace, and then there could be 2. In this case, it's a function with 2 pieces, but there could be 2, 3, 4, 20 pieces. Okay? Each piece will be a formula, some expression, and then over here you're gonna be specifying what portion of the domain corresponds to that piece. Okay? The domain is going to be always spelled out for you right here. Okay? Like the excess corresponding to that piece. So here's an example of a piecewise function. Okay, so and then when you graph it, the way you think about it is, let me color code this a little bit. So I'm gonna put this one in red, and then I'm gonna put this one in blue. So when you graph it, you do it piece by piece. For example, the first piece is the function y equal x, but you only care about it as long as x is greater or equal than 0. So from the entire graph of y equal x, we are only going to borrow this portion. Okay? Okay, I will complete the story here pretty soon. But let's do that example that I mentioned down there. I'm gonna complete the story right now. So first, let's look at the function f of x equals 2x plus 1 if x is less than 0, and x squared plus 2 if x is greater than or equal than 0. And then we want to evaluate the function. Let's find f of -1. Let's find f of 1. And we find f of 0. Okay, so and again, what this boils down to is to understand what piece you need to use, right? So what formula, and then you plug in the corresponding formula. So if we want to find f of -1, what piece do we need to use? Is it the first or the second piece? So you need to ask yourself, my input is -1, where does it fit? This part right here is what talks about the input, right? This is x. Well, -1, where does it fit here? It fits right here. -1 is less than 0. You understand that? So that means that you should be using this formula anyways to evaluate this. So this would be 2 times -1 plus 1. Does that make sense? So what do we get? -1. All right, second piece. So the second one, f of 1. What piece do we need to use? We use the second piece because 1 is greater than 0. So this input satisfies this condition, right? Not this. By the way, these things, the condition has to be mutually exclusive, meaning they cannot overlap. Otherwise, you could have conflicts, okay? And you may not have a function because if you use 2 formulas for the same input, you have to make sure that you get the same output. Otherwise, you no longer get a function, okay? So typically, the things here is either here or here, but not on both at the same time. Okay, so here we use the second one, so that would be 1 squared plus 2, so that gives 3, okay? And then f of 0, what piece do we use? The second one, very good. Notice that the second one is x greater than or equal to 0, okay? The first one is only for less than 0. So we use the second formula, so the answer here will be 2. Is it clear how to evaluate piecewise functions? Yes? Okay, now of course, now that we understand how to evaluate, like I said, domain is not really an issue. The domain is always spelled out here for you. What's the domain of this function? What's the domain of this function? It's already a number, so you can plug in whatever you want. You come in with something negative, use the first piece. You come in with 0 or positive, use the second piece. Okay? Everything is here. Domain is not really a problem for piecewise functions, but then the question is, how do you graph piecewise function? Okay? So let's graph this example. So note, to graph piecewise functions, just do it piece by piece. That's it. For example, for the absolute value, we don't really need to memorize the absolute value graph if we understand the graph of these 2 little lines. Okay? If you want to graph the absolute value, you say, okay, my first piece is the function y equal x. So you draw that one. Now I'm gonna draw it like this first. this is the function y equal x. But then, do I want the entire graph or I only want a piece of it? Well, I care about this as long as x is greater than or equal to 0. So that means I only care about this portion of the line y equal x. So the rest, I don't care, because when x is less than 0, we are looking at another formula, right? Now I go to the next piece and repeat. We have the function y equal negative x. That happens to be, this line over here. Once again, we only care about this one as long as x is less than 0. So that means we only care about this part over there. So we don't care about this one, so we erase it. And now, it turns out that you get your usual b function, b shape, etc. But this is really, when you put 2 functions together. Okay, this is how you graph piecewise function, one piece at a time. So, for example, let's graph the function that we have above, and then I guess the next time we do a couple more examples. But with this, you should be able to do homework and everything is coming from there. So, sketch the function f of x equals 2x plus 1 if x is less than 0. And since we're here, let me just encapsulate everything at once. Let's say 7 if x is equal to 0. Then let's say x squared plus 2 if x is greater than 0. So this time this function has 3 pieces. Okay? It's just the piece in the middle. How does the piece in the middle look like? What is this? Yes? It's just a point. Very good. So when x is 0, you no longer look at this formula or this one. When x is 0, y is 7. So this is a point 0, 7. Okay? So let's see how the picture of this will look like. So, I could do the long way, but then I only have 5 minutes. So I'm going to do everything at once, and then on Tuesday, I'm going to do more examples, a little bit more relaxed. Okay? But the way it works is as follows. Actually, no. I'm going to call this piece number 1, piece number 2, piece number 3. So piece number 1 is a function y equals 2x plus 1. This is easy, so we can do it fast. So y equals 2x plus 1. Just draw it. Okay? So draw that piece. So this is a line. Now you should know how to sketch lines, right? So you only need 2 points. What's the y-intercept here? Is 1. So it goes through this point. And then what is the x-intercept for this? What will be the x-intercept? It's 1/2, negative 1/2, right? So negative 1/2. So right here, negative 1/2. So we're talking about this line. This is the line y equals 2x plus 1. Now, do we want the entire line? Well, let's see. We are only interested in this as long as x is less than 0. So x less than 0 is this portion of the graph. Okay? So that's what we're going to take. So I'm going to go here. I'm going to start building my picture. This right here is my picture. So now I copy and paste. Okay? So this portion, I copy and paste it there. So negative 1/2, 1, and then we have our line in there. Okay? Now, this point, you always have to be careful. So let's see. This point right here is when x is equal to 0, right? So when x is equal to 0, are we looking at that function? No. So, because we're not looking at that function, I'm going to do an open circle. This is a way of saying when x is 0, we're not looking at this piece anymore. Do you understand this? Let's go to the next one. So, technically, if you want to follow the same thing, technically the next one is the function y equals 7. But, we are only interested in what happens when x is 0. In other words, y equals 7, as you know, is, a constant function happening here at 7. But from there, we're just borrowing this point. We don't care about anything else. Okay? So, cut that little point from there, paste it down in a graph. So, I don't know, I'm going to put 7 up here. And then you do that by putting the point. So now you're saying when x is 0, you're no longer here, now you're up here. Okay? Now go to the other piece and repeat. So you do this piece by piece. What's the other piece? X squared plus 2, but we only care about it when x is positive. So you just sketch quickly the x squared plus 2. You know what it is. It's a parabola shifted up 2 units, right? It looks like this. So this is a 2 here. Now we only care about it when x is positive, so that means we are only taking from it the right part, okay? That begins at 2. Now here at 2, we're going to do an open circle once again, and then we do our parabola. Any questions? So make sure that what you draw is a function. So for example, if you are slowly and you draw your parabola going this way, it's going to violate the vertical line test. You get 0. Okay? 2 open circles because we have a closed circle here already. Alright. Remember, the exam is a week from today. And if you want your exam back, you can pick it up now. That's it. So, last name?